I'm here with Asfand. Is that
Asfand,
correct?
that's it, correct.
He's from
Perfect.
Aurora 3D.
Yep.
Tell us about what you guys do.
Well, we build a 3D scanner that's powered by a smartphone. So essentially, it's the opposite of a 3D printer. What it does is you put an object in front of it, it's got a green laser, sweeps across the object, and basically turns it into a digital model.
Right, how does the smartphone work?
Well, the big thing about the smartphone is that you have a camera on it, a really high quality camera, and today's smartphones are really, really powerful. So what it does is basically, as it scans across the object, the laser scans across the object, it uses the smartphone to essentially rebuild that object in 3D. So it analyzes that line as it scans across the object.
Why a smartphone and not just a regular PC?
Well, because smartphones, it's something that everyone has, and it's a big factor in reducing cost. So what happens with the 3D scanners, you need three things. You need a camera, you need a lot of processing power, and you need a laser, basically. And two of the three are in a smartphone. And pretty much everyone's got a smartphone. So
why not?
By bringing your own smartphone, you essentially reduce the cost.
Got it. All right, show us the hardware.
Well, here it is. This is the prototype.
This is the prototype.
This is the prototype.
On a breadboard. Okay, so we've got our smartphone. So the camera is, of course, facing the object here.
Our object there.
And it has to be on a black board.
Basically, just to get rid of the background. Doesn't have to be. Can be any color. Doesn't matter.
Okay.
Because we're in a public space, you know. Just to get rid of the background.
But it can't be a complex background. Otherwise,
it can be anything. It can be, as long as it's stationary. It can be any background.
Stationary. So it uses motion to
detect.
Right,
Exactly.
Got it. What is on the breadboard?
Well, the breadboard is actually we've been using for a while now.
Yeah.
We have an Arduino in there, Pro Mini. We have a DRV8834 motor controller, and we've got a couple of voltage regulators, but it's 100% Bluetooth now. That's our Bluetooth evaluation board, so the Arduino is actually doing nothing at the moment.
Right.
So it runs off an ARM M0, and everything's Bluetooth controlled from the smartphone.
How did you get that here in one piece without it?
We have a bit of experience with that now.
Right,
so.
okay. All right, so show us. Can we see it doing
Run
something?
a scan? Yes, absolutely.
Let's run a scan.
All right, so what I'll do is I'll restart our app. You press scan. Object comes up. Essentially, the object a little bit in the field of view. There we are. And we just press start.
Go. And we can't see the laser.
It'll come up.
It'll come up.
Give it a couple seconds.
And it's a green laser?
It's a green laser.
Yeah, oh, there it is.
So there we are.
Scanning across.
So basically we use a green laser because it's essentially twice as sensitive.
Right.
Most CMOS sensors are twice as sensitive to green compared to red or blue. So we get basically better sensitivity. So what it's doing now is just setting exposure, and then it'll sort of sweep back on itself and it'll start scanning the object.
Why did it sort of do it in little bursts? Is it caching the data? And
basically what it's doing is it's trying to sample the entire scene first, and it's trying to essentially get the exposure setting.
Right,
so just to see how much light, how much brightness you adjust the camera for, and then it's doing the scan right now.
Got it.
So what it's doing, it'll take about 2 to 3 minutes for it to scan across. So right now what it's doing is essentially taking snapshots of the object and then analyzing the beam as it goes across.
I can see it moving a little step each time.
A little step each time. So what we've tried to do here is try to build a really high precision scanner. There's a couple other scanners on the market, but they're very their accuracy is really for big objects is okay, but for something like this we want something that's very high accuracy.
Got it. And you guys have made this little thing, the scanner itself, or is it just basically some nice packaging?
No, basically 100% electronics, coding, industrial design, everything's done by us. Basically, us funds, Rahul and Richard in the back. We're the three co-founders, and we're basically going to Kickstarter end of September. That's
Fantastic.
our launch date for our.
What's your goal?
Goal will be about 80,000 or so.
Okay, that's doable.
Yeah.
Sure.
Just for the nature of our products, we think it's a good goal to have.
And next week you're at the World Maker Faire, is that right?
Yes, basically September 27th is the World Maker Faire, and we intend to launch at the World Maker Faire.
Fantastic.
And probably going to be kickstarting the campaign literally at the event. Yeah.
How many other 3D scanners do you expect there?
Probably a few, but
A few dozen, I suspect.
But I don't think there'll be one exactly the way our scanner is, and especially at the price point.
Right.
Early bird is
What are we
basically
talking
$199.
$199.
Early bird price point for Kickstarter.
Gee, yeah, that
So
sounds pretty good.
I think you'll be hard pressed to find something in that price range.
Can we see the electronics inside one, or you don't have one?
Electronics inside one.
Oh, that's it. There we go.
There we go.
There we go. Have a look at it.
If we had one more day,
Yep.
this would have been working.
Right, okay.
So basically, if you have a look at it,
Yeah.
that little Bluetooth little module there,
Yep.
that's the little unit right on there.
Got it.
That's development board,
Yep.
and here's our actual own circuit. So everything's been done, just got to upload the firmware, and we're good to go.
Yep. And that's got a little stepper motor driver in it, does it?
That's
that
got
moves
the that's the
laser
DRV834.
Yep.
That's the step motor driver, Bluetooth controller, couple of filter caps and little
Yep.
things here and there.
and that's it.
Yeah, that's it.
Awesome. Oh, thanks, mate.
No worries.
Good luck at the Board Maker Fair.
Thank you for that. Thanks,
Yeah.
David.
All right, I'm here with Matt. You may have heard of, well, you haven't heard of Matt, but you've heard of his company, Breadboard Killer. So tell us all about it. What do you do? Show us.
Yeah, well,
some
we
stuff.
are a printed circuit board supplier in Australia. We started off batching orders together of printed circuit boards, and that started about a year and a bit ago. And so it's like a side thing for me. So I started off doing that, and my goal is to bring it back to doing that, but at the moment we're offering more flexibility so you can kind of order your boards with like custom solder masks and stuff like that, and you can get like 4/4 out tray spacing if you need to.
4/4.
Yeah, you can get down to 4/4, which is I haven't had anyone do that yet. Yeah, which is pretty insane.
That usually costs a lot more to get down to 4/4.
Yeah, it does cost a bit more. I think it's $40 extra. So,
Right.
but yeah.
Yep.
So it's an Australian printed circuit board supplier.
Yep. How much are your boards?
So if you want a 5x5 centimeter board,
Yep.
it's $25 plus shipping, so that ends up at $36.
Yep.
Or if you wanted a 10x10 centimeter board, it's only $5 more, so it ends up as $46 with the standard shipping.
And how many boards do you get?
You get 5 boards.
You get 5 boards for that.
Yep.
It's incredible. When I was a boy, let me tell you, you get one board for like $800.
Oh yeah. That seems worth it.
Fantastic. So we obviously know where they're made. They're made in China.
They are, yes.
Do you take the files manually and do it, or do you have like a OshPark type
Yep.
automated process to do it?
So for a 2-layer design, you can upload your Gerbers directly to the website. You can like just zip your files and drag and drop them, and then you can kind of like select, which layer goes where if it's not a standard format. Otherwise, it'll guess which layers are which if you're Altium or Eagle standard outputs.
So does it show you on the website? Does it show you like a preview of the?
Yeah, it does. If I can get it to show up at some point, or I can show you on my laptop. There you go. So you kind of just like drag and drop your file.
Yep.
It'll upload. And then you can see renderings of your board.
Very nice.
You can see the layers, and you can select which way is which and all that kind of stuff. Then on the next page you can like select solder mask and it'll render it in red or whatever, so you can see the colors and stuff like that.
How long will it take you to put together? To
Yeah.
code, all that sort of stuff. Is that easy?
Not super easy. It took about 150 hours of coding.
Is that all?
Yeah, I don't know. I feel like that's a lot.
Right. Okay.
I don't know.
Right.
Yeah. So and then I mean that was like to do the base stuff, and then I've just like kind of progressively work on it. It's kind of like
So do you panelize batch them with other? Is that how you do it on one batch panel?
No, not at the moment. The manufacturer I use actually panelizes them, so that's what gets the cost
Right,
down.
they-
But
they
they aggregate like orders from a lot of other people.
Right,
and
so they
panelise
actually
them.
do it for you. So you just
pretty
send them a
much.
bunch of individual files.
That's
and
right.
they
Yeah.
will- Right.
Yep.
Okay.
And so my goal is to move it towards in the future. I want to be more like the OshPark of Australia.
Got it.
And
Yep.
like there are a lot of people in Australia who get PCBs manufactured, and I want a low-cost service that's quick turnaround, thus the Breadboard Killer. If you can
exactly.
replace the breadboard, then bloody go ahead and do it. I think it'd be awesome.
Fantastic. And sorry, the lead time is? Did you mention that?
So at the moment, if you use standard shipping, it's about 3 weeks from when you order it to when you receive it. And if you go express shipping, it's a week and a half.
That's pretty good. Week and a half.
Yeah.
That's not bad at all. Yep. Any plans for like a real express service, like a 2-3 day turn kind of?
Not at the moment, but I have to see if there's like some demand for it. If people like really want that, I tend to find like the price really skyrockets when you look at that, like
does.
$250 a board. And I mean, most hobbyists makers, which is who this is mostly aimed at, people like me who want to, like get their prototype up and working, you know, don't want to throw $300 to get your design here like a few days or, you know, a few weeks earlier or whatever. Yeah.
All right. Yeah. So mostly Australian clients?
Yeah.
Yep, pretty much.
Very large majority is Australian clients, yep.
Thanks, Matt.
Yeah, you're very welcome.
Check them out. Breadboardkiller.com.
.au.
Yeah. Oh, I got the Australian one. Yeah, just to be Aussie. All right. Thanks, Matt.
You're welcome.
And I'm here with Peter from Robots and Dinosaurs. He's going to tell us all about his funky. What is it?
This is a video game, Kerbal space program. I have built a hardware control interface to let me control what I'm flying in the game and give me readouts about the status of my ships.
Got it. So it's basically a custom hardware interface to an existing the Kerbal space program.
That's right.
So otherwise people normally just operate it with a joystick or whatever. And
with a joystick, your keyboard and mouse.
Keyboard, and it's just not as fun.
It works great, but it's kind of boring.
Yeah, right. Well, tell us about the hardware. What's running it? What's it got?
So I have 2 Arduinos on board. One of them manages all of my switches and my dials and has a serial connection back to the game. I have a second Arduino that just manages these displays and the LEDs.
Got it. And all of these light up?
They do light up. They're not right now.
This is for launching?
A lot of it is good for launching. Yep. I've got parachutes and heating, so I get to find out if I'm about to explode.
Got it. Where is the ACE to aux button? We need an ACE to aux.
That's coming in version 2.
Right, excellent. How long did it take you to build?
About a year and a half off and on.
Yep.
Started planning around January last year. Mm-hmm. Started buying components around March last year. I mostly finished it this week.
Oh, fantastic!
Just in time. I was crunching fairly hard. Yes.
Fantastic, and we can drive a rover on Mars as I did yesterday.
Yes.
Fantastic. So, what else we've got? We've got some. I love the analog VU, the analog meters.
Those currently aren't hooked up, but they will be. Oh, that's also coming very soon.
Right. Got it.
I'm intending those to show my speed and descending and altitude. Right. They'll be beautiful for landing with.
And I love the blue LED displays.
Those are absolutely gorgeous.
They are gorgeous, aren't they?
Bought those from our friends at Little Bird here today.
Oh, fantastic. So what do they show? What can you program
I can program them to show all sorts of things. When I'm in orbit, I can show my apoapsis and periapsis, which are highest and lowest parts of an orbit. I can show how much fuel I have on board. None right now, because this is an electric rover. I can show when I plan for a maneuver, I can show how far away that is and how much power I need to use to get there. And I can show my altitude. So right now it's telling me that we're at 2 kilometers above sea level. And that's about it.
Sea level on Mars?
Where the sea would be.
Where would be, right. I guess there's a mean level where they, just like on,
Yes.
Got it. Fantastic. Thanks, Peter.
Thank you.
Now here with Ian. Tell us about your podcast.
Hey, I've got a weekly science technology if you want wacky, weird, unusual, funny science every week.
Awesome.
Diffusion Science Radio at diffusionradio.com.
Diffusionradio.com. There you go, folks. Show us your stuff. Well, see, he's wandering around with his podcast.
Running around with my equipment.
People with his microphone.
That's right.
Show us your other stuff.
Got the NeoPixel goggles.
Yep.
And
nice work.
Yeah, good fun.
Oh no, you've got
put them on.
You've got
put them on like that.
Yep. Woo! Awesome. And you've got a head-mounted camera.
And I've got a little head-mounted camera.
Is that permanently on?
It's not permanently on.
Oh, right. It's just.
I don't have the battery for it. Look, it's a Luxi that I've modified.
Yep.
And Luxi don't make them anymore.
Right.
So it's not fully supported anymore, and it's better if I just record when I want to record then switch it off.
Got it. Awesome. Thanks, Ian.
Thank you.
I'm here with Nathan from the Uni of New South, and he's going to tell us all about these fantastic little Pacman robot things. Take it away, Nathan.
So we're a group called Create at the University of New South Wales. We're a maker club, and this is our latest project. So this is a robotic Pacman game.
Excellent. And tell us about the tech in it.
So, these little robots are running Arduinos inside of them. We've got these stepper motors on the bottom here, which are exactly the same as the ones in your 3D printers. Yep. And they're used to drive the robots around with these omnidirectional wheels that allow the robots to sort of move forward, back, left and right without having to turn. And we're using these infrared sensors to do some line following, basic line following, on an interactive course with some image recognition.
Because you've got some LEDs in here, and they're the dots, right?
Yeah, they are.
So they're the dots, and the Pac-Mans eat the dots.
Yep, so as Pac-Man moves around the course, we've got a little overhead webcam, and it keeps track of Pac-Man, and it turns off the dots as Pac-Man goes and eats them.
Fantastic. And where's the webcam?
The webcam's all the way up there, that little tiny little green dot. And I can even show you a little bit of what it looks like on this program. So we've got Pac-Man moving around, and the webcam is actually tracking where Pac-Man is. And we've got the blue ghost obviously on screen as well.
Fantastic. How long did it take you to put this together?
Oh, about 5 weeks.
About 5 weeks?
So not very long.
Okay, so you did this actually for the fair?
We did it, actually it was originally for Vivid, but we've improved it since then and made it ready for the fair. So
I didn't see this at Vivid.
No, it was actually at UNSW Art and Design campus to begin with, so it was a bit off-site, but this is such a massive event, we've wanted to show it here for a long time.
Does it play a mean game of Pac-Man?
Oh, it does. It's a work in progress. So we're setting up a Wi-Fi network to send all the robots information about the location of all other robots, so they can make smart decisions, so that Pac-Man can avoid the ghost and the ghost can chase after Pac-Man. It's really exciting.
Good work. Thanks, Nathan.
Thank you very much.
I'm here with Aileen from the Missing Link, and she's going to tell us all about this. It's not chainmail. What is it?
It is scale mail.
What is scale mail?
Scale mail is made with a bunch of tiny little scales, like this, or like this, and they're all joined individually with links, kind of like chainmail.
Awesome.
But instead of joining up the links to themselves, they link into scales. Now, this style of armour has been around for ages.
Since before chainmail?
Yeah, actually, it was a precursor to chainmail. It was about 1,000 years beforehand, was about when it started.
Wow.
The Japanese were very fond of it. They used to make it out of paper, leather, metal, anything that they could come to hand.
Yep.
The scales weren't necessarily this shape. They were, other shapes. They used to have them in squares, in rectangles, things like that. And they joined them up with either links or leather, or they'd tie them on.
Got it. And how long does it take to manufacture that?
This took me 22 hours.
22 hours, is that all? I expected more than that.
I'm pretty fast.
Oh, right, okay.
Yeah. The chain around it, the actual custom bandolier to hold it on, that took me 6 months.
6 months?
It was the first piece I ever made. I was just learning at the time. And it gave me a good basis.
Fantastic. Thank you very much.
No worries.